Okay, so here we have an empirical formula problem, and we're also given here the molecular weight. This is going to allow us to determine a true formula for the compound as well, something we can't do unless we have the molecular weight of the compound. Alright, so we're going to start out with the number of the percentages here, 37.21% for the carbon, 7.83 for the hydrogen, 54.96 for the chlorine. And if we have 100 grams of compound, then each of these can just be considered to be the number of grams we have in that compound then. So we'll start out with the carbon here. It's going to be 37.21 grams of carbon. And what we're going to do is we're going to find the number of moles first. The relationship here will be grams of C on the bottom, 1 mole, 12.01 grams of carbon, and that comes out to be 3.09 moles of carbon. We'll do the same thing for hydrogen, 7.83 grams of hydrogen times grams of hydrogen on the bottom, moles of hydrogen on top. 1 mole of hydrogen is 1.01 grams of hydrogen. That's going to be 7.75 moles of hydrogen. And do the same thing for chlorine. We've got 54.96 grams of chlorine. Grams of chlorine go on the bottom, moles of chlorine go on top. 1 mole of chlorine, 35.45 grams of chlorine. That's the atomic weight. That's going to come out to be 1.55 moles of Cl. The next thing we want to do is we want to take the smallest one, which is 1.55 moles of Cl, and divide it through on each of these to get our mole ratios. So 3.09 moles for the carbon divided by 1.55 moles. For the chlorine, that's going to be 1.99, which we're going to go ahead and round to 2. So this will be for the carbon. Next we'll look at the proton or hydrogens. We've got 7.75 moles divided by 1.55 moles. That's going to come out to be 5. So that's for the hydrogens. And for the chlorines, we've got 1.55 mole divided by 1.55 mole, which will of course be 1, so that's for the chlorine. So you can see that the empirical formula here is going to be, well, it's going to be C is to H is to Cl is going to be 2 is to 5 is to 1, so it'll be C2 H5 and Cl. Now in order to get the true formula, what we're going to have to do is figure out the mass of the C2H5Cl, and what we're going to find is that's going to give a certain mass, and that would be around about 64.1. So that's 2 times carbon plus 5 times hydrogen plus a chlorine. And then what we can do is, that's grams per mole there. And what we'll do then is, I'll delete this here. Is we now have the molecular weight, which is 385 grams per mole. We'll divide that by the empirical formula weight, which is 64.1 grams per mole, and we're going to come out to a value that's pretty close to 6. So what that means is that in each of these true formula units, we've got 6 of these, so all we have to do is take the 6 and multiply it by C2H5Cl, and that's how we'll get C12H30Cl6.